Hi, welcome back. I am Nisha. In this session, we are going to talk about how to search a particular value from an integer array. So, in the last session, we already discussed about searching an element, but that is linear search. The linear is very simple and convenient for small arrays, but when the array is very large, linear search is not suitable because it will take more time for the process. So, from the first element onwards, we want to search it and we want to find out the value. But here if it is very large, we can choose binary search method. So let's see what is binary. So what is binary search? So here bi means two. So binary means something made of two parts. So here binary search, we are searching an element in an array. So we are making that array into two parts. Why? What is the use? So just see. In binary search, the first point is the array must be in sorted order. But how to sort? What is sorting? Sort means making the array into ascending or descending order. So how to sort, that I'll discuss in the next session. So here we are going to study binary search. So just we can assume that array is in sorted list. Okay. Now see the second point. Declare a variable for the search element. So we need a variable for that searching. Then accept the search element in that variable. So we want to input a value in that variable for searching. Now how to find out? See, find the middle position. Find the middle position because array is in sorted order. We want to find the middle position of that array. And check the middle element. And we can check that middle element with the search element. If the middle element is equal to that searched value, then the position has been found. Is it? Yeah. Otherwise, the upper half or lower half is chosen for search based on whether the element is greater than or less than the middle element. If the element is greater than the middle one, we can move on to the second half of the array or the upper half of the array. Or if the middle element is less than that value, then we can check the first half or the lower half of that array. So this is called binary search. Okay, here I'll show you one example. Then you will get the clear picture of binary search. Okay. Now see the array. List is the array name. Then 10 elements are there. 0 is the first index number and 9 is the last index number. So see the elements all are in ascending order style. Is it? Yeah. Increasing order. All the elements are in increasing order now. And this is the element we want to search it. Item. This is the item we want to search it. 83. So in binary search, first we want to find the middle position of this array. So how we can find the middle position of that array? 0 is the first, 9 is the last. So how we can find the middle one? 0 plus 9 divided by 2. That means 4.5. But only the integer part we can check it because integer part only we'll use for the index number. So 4 is the index number. See, the middle position is now 4. Okay. So which element is there in the fourth position? In the index number 4. That is 43. So now we are comparing. Is that 83 is equal to 43? No. It is equal. We got the element at the first checking itself. But now it is not. So what is the next step? Next step is we are comparing that 83 is greater than 43 or 83 is less than 43 because it is in sorted order. So we can check it through that way. So 43, is it 83 is greater than 43? Yeah, it is greater than. So that means we don't want to check the first half of this array now. Okay, so we can hide that portion now. Understood? Now, the first element of this array is 5, index number 5, and the last one is 9. So, the same process we are repeating here. So 5 plus 9, 14. 14 by 2, 7. So 7 is the middle portion. Now we are checking the middle element. That is 83. So 83 is equal to 83. Now we got the element. Is it? Now we got the position of that 83. So we can print that 83 is found at position number 8. So index number 7 and the position is on 8. Understood? Okay, so one more example we can check it. Now the fresh array, the same elements itself, it is in ascending order and we can check with the new value that is 17. Okay, now we are moving on to the middle portion, that is the process of binary. So first we are finding the middle portion is 4, so 43 is the middle element. We are comparing, is it equal? No. Then the next checking is it greater than or less than? So 17 is less than 43. So we can hide the second half portion of that array now. Now 0 portion is the first element, but the last element is not 9 now. The last element is 38. Is it? That means the portion number 3. So again we can find the middle one. So how we can find the middle one? Same process. 0 plus 3 by 2. That means 1.5. So only 1 we can take it here. So 1. What is there in the 1? Index number 1, 17. Now we got the element. 17 is equal to 17. Now we got the position of that 17. It's in the position number 2. Understood? So this is binary search. Okay. So now we can check how to solve this, how we can do it. So first we can move on to algorithm part. Okay. So here it's an algorithm for binary search. Let's see. Step 1 is start. Step 2, accept a value in n as the number of elements of the array. So n is the variable we are using for setting the limit of that array. Then step 3, accept n elements. So here we are inputting the values in the array. But here we want to enter the elements in the ascending order. Then only we can do that binary search method. So at the entering time, be very careful to enter the elements in ascending order style. Then step 4 is accept the value to be searched in the variable item. So item is the variable here we are using for searching the element. Now step 5, store the position of the first element of the list in F, position of the first element in the F and the last in L variable. Okay, so we need 2 extra variables here for storing, for setting the first position and the last position. So the first position of that first element in F and the last in L. So first time F is equal to 0 because in array the index number starts from 0 onwards. So F is equal to 0 and the last is here n is the limit. So n minus 1 is the last. Okay, so L is equal to n minus 1, F is equal to 0. So that is the first step. Then on next step, step 6, repeat. So we want to repeat the process, which all process 7 to 11 we want to repeat it. While F less than equal to L, F less than equal to L means F is 0 now, L is n minus 1 now. So we want to repeat the following process till F is greater than L. Okay, so now if the F is less than L because F is 0, L is n minus 1. So what we want to do? Step 7, find the middle position using the formula F plus L whole divided by 2 and store it in mid. So find the middle position. How we can find the middle position? The first index number plus the last index number. So that is 0. That is in F now. F plus L whole divided by 2. We will get the middle position. That we can store it in the mid variable. So mid, one more extra variable we used. This is for finding the middle position. Okay, now we got the middle position. Now step 8. Compare the search value in item with the element at the mid of that list. So we want to compare the element. Which element? What is there in the middle position and in item. This we are comparing. Okay. Now step 9. If the middle element contains the search value in item, then stop search. So if we got it the first time itself means we can stop searching and display the position and go to step 12. That means we are ending the program. But if the search value is smaller than the mid one, if that item value is smaller than the middle element, so then we want to then set L is equal to mid minus 1. L is equal to mid minus 1. That means we want to hide that second half. We can avoid that second half of the array. Okay. Now the last element is mid minus 1. L is not n minus 1. Now it is mid minus 1. Okay. So half portion we avoid it. Now in step 11, if the search is larger than the middle element, if the search value is larger than the middle element, then we can set the first, f is equal to mid plus 1. That means we are avoiding the first half of that array. Okay, so for that f is equal to mid plus 1. So this, after this, again we want to repeat the same process because f is less than equal to L. So again we are doing the same thing. So again we are finding the middle position and we are storing it in mid and we are comparing the search item with the middle element. If it is equal, we can display the position and go to step 12. That means stop. If the search value is smaller than the middle element, then we can set L is equal to mid minus 1. If it is larger than 1, then f is equal to mid plus 1. So this process will continue till f is greater than L. Okay, so this is called binary search. So this is the way of writing the program. Now we can check C++ program. So here now we can check the C++ program. First program begins with main. Then we are declaring the variables. List is the array name, maximum 25 size. Then n is for number of elements. Then first, last, mid, item, location. So these are the variables we declared first. Now next is how many elements you need. So see in n elements we need here. Okay, so for that we want to input the array now. So enter the array elements in ascending order. That is very important because it is binary search in ascending order. So for loop begins, I is equal to 0, I less than n, I plus plus. We are inputting C in list of I. List of I means that is the array here. So n elements we got it in array list. That is also in ascending order. Now the next is we want to search a particular one. So which element we want to search it? So enter the item to be searched. We want to input an item. That is the variable we are using for inputting, for searching. Okay, so item variable. And the next is we want to search it in the array now. So first we want to find the middle position of that array. So how we can find the middle position? So first is first, the value of first and last we want to set because we didn't initialize here. So we can set the first value of first and the last. First is equal to 0, last is equal to n minus 1 because n elements are there. So n elements means the index number shows n minus 1 only. Okay. Now the loop begins. While first less than equal to last. If first is less than equal to last, then do the process. So what is the checking here? So first we want to find the middle position. So mid is equal to first plus last whole divided by 2. So we got the mid value in mid variable, middle value in the mid variable. Now we are checking if item is equal to list of mid. List of mid means mid is the index number, position number here. So list of mid, we'll get the middle element. Is it equal to item? Yeah. If it is true, we can set the location as mid. So we got the location. First time it is minus 1. Now we change to mid. Then we are break. Break means we can exit from the loop. So that is the first checking here. if item is equal to list of mid. List of mid means the middle element we got. If it is equal, we got the location and we can exit from the loop. Okay. But if the condition is false, now we want to check the second condition. What is the second one here? See. Else if item less than list of mid. If the item is less than of the middle element, is it less than the middle element? Yeah. If it is less than means what we want to do? We want to change the last value. Last value is n minus 1. That we want to change it to mid minus 1. Is it mid minus 1? Because second half portion we are omitting. Okay, so now the item is in the first half portion. So we want to check that one only. So if the item is less than the list of mid, last is equal to mid minus 1. Otherwise, if the item is greatest, what we want to do? Yeah, we want to set the first is equal to mid plus 1. Understood? So these are the checking process. If item is equal to list of mid, we will get the position and we can break it. Otherwise, if item is less than the list of mid, last is equal to mid minus 1. That means we are omitting that second half portion. Otherwise, else, first is equal to mid plus 1. That means if the item is greater than the list of middle portion, then we can avoid that first half portion. So this process will continue. First is if the first value is less than equal to last only. Okay, so when we complete the loop, we got the element, we can break it. Otherwise, there is no element. Location is on the minus 1 position itself. Understood now? So this is the process of binary search. Now we can print the position by checking the location value. See, if location not equal to minus 1, not equal to minus 1, that means we got the element now. So the item is found at position location plus 1. Location means that is index number. So location plus 1. Then otherwise else we can print the item is not found in the array. Got it? So this is the binary search program. Now we can check the example here. See, list, these are the elements. It is in ascending order now. Now we can check the value. Location is minus 1 and the item is 83 here. This we want to check it. So the first is what? At 0th position. Is it? So first is on 0th position and last is on 9th position. Okay. Now we want to find the middle position. How we can find the middle position? Yeah, 0 plus 9 divided by 2. That means 4.5. We'll take only the integer part. So the mid is on 4th position. Okay. So we got 43 as the middle position value. Now we are comparing. Is it equal? No, it is not equal. So the next is what? See, it is not equal. So is it item less than equal to mid, list of mid? List of mid is this 43. Is that item is less than 43? No, it is not less than 43. So else. Else means item is greater than that mid position value. Is it? Item is greater than this one. So the first is equal to mid plus 1. So first is equal to mid plus 1. So this first is 0 now. So first position is moving to where? On mid plus 1 position. Okay, that means we are avoiding the first half of the array. So first is moving to which position? On the 5th position. Now first is on 5th and the last is on 9th itself. Okay, now we can find the middle position. So 5 plus 9 divided by 2. So 7. Is it? So 7 is the middle portion now. So now we can set 7 as the middle one. Now we are checking. Is that middle portion value is equal to 83? Yeah, we got the element now. Is it? Yeah. Now we can print the position. The 83 is found at position number 8. Understood now? So if it is less the value, we'll avoid this second half and we'll go through with the first half value and check it. So this process will continue. If the first is greater than the last, then we can exit from the loop and we can check the location, is it -1 or not. Clear? So this is binary search program. Okay, here one more example we can check. The program is same and the array list. This is the array. It's in sorted order. 10 elements are there, 0 to 9 index numbers. And the location is -1 and the item we want to find is 17. So the first step is we want to set the 0th as first and the 9 is last. That is here. So after finding the after inputting the item, we want to set first is equal to 0 and last is equal to n minus 1. So n is 10. So n minus 1, 9. Okay. So first on 0th position and last at 9th position. Whole divided by 2, that is mid. So we'll get 4.5. So that is middle position now. Okay, so we got the middle one. Now the next is if item is equal to list of mid. List of mid means array list of mid of 4. List of 4. Is it equal to item? Item is 17. List of 4 is equal to 43. It's not equal. Is it? So this condition is false. So else if, so the next checking is it less than or greater than? So else if item less than list of mid. So we are checking with, is it less than of that middle item? Yeah, 17 is less than that 43. Is it? So what to do? If it is less than, last is equal to mid minus 1. Last is equal to mid minus 1. So last is on 9th now. So we want to change it to mid minus 1 position. That is last. Okay. So last is equal to mid minus 1. So now last is here. Okay. Next is what? See, we set this last value and the while loop is closing braces there. So we want to move on to the test expression again. Is that first value is less than equal to last? Is that first value is less than equal to last? Yeah, first is on 0, last is equal to 3. Is it? So it is less than. So next step is what? Mid is equal to first plus last whole divided by 2. That means 0 plus 3 by 2. 0 plus 3, 1.5 we will get it. Is it? Yeah. So mid is on 1 position. So mid is there on the first position. 1. Index number 1 position. Okay. Now we are checking. Is it that item is equal to last of 1? List of 1. Is that item is equal to list of 1? List of mid. Mid value is 1 now. Is it equal to 1? Yeah, it is. See, both are 17. 17 is equal to 17. Item is 17. List of 1 is equal to 17. So both are equal. So if it is equal, we can set the middle value to that location. Middle value means that mid, that position, mid to location. So now the location is -1. So we got the value now. Now we can set this 1 in location. So the value of location is now 1. Index number is 1 here. Okay. Now we can break the loop because we got the element, we got the middle value. So we can exit from the loop. So after exiting from the loop, we are checking the location. If location not equal to -1, is it location is equal to -1? No. So it is not equal to. So what to do? So the item is found at the position. So the item is which one? 17. 17 is found at the position location plus 1 because location shows 1 but the position is 1, 2, second one. Is it? So we want to print it as the location plus 1 is on the position of 2. So now we got the result. 70 is found at position number 2. Got it? So this is binary search. So it is very easy to do in internal way also. So it is this binary search is very important one for the array, sorted array list. If it is very large array, we can choose this binary search method. Clear? So binary search is used in 99% of 3D games applications. So it's very useful for the higher classes. Okay. So the logic of binary search is comparing the target value to the middle element of the array because that array is in sorted order. If it is not equal, we are eliminating the half portion and again taking the middle one, and we are comparing the target value, and the process is repeating until the target value is found. So this is binary search. When you are comparing with linear search is very simple, but it will take more time to process because it will take searching started from the first position onwards, is it, till the end. So binary will take very less time for the process, and it's suitable for the very large array. So I hope you all understood the concept of this binary search. So see you with a new topic the coming sessions. So till then, take care. Bye.